Hello everyone, in this video tutorial, we will see how we can integrate YOLO-NAS with DeepSORT object tracking algorithm and how we can do object tracking using YOLO-NAS on custom dataset. So in the first step, we will integrate YOLO-NAS with DeepSORT object tracking and test it on pre-trained YOLO-NAS weights. In the next step, we will train the YOLO-NAS model on a custom dataset and integrate DeepSORT object tracking with it. In object tracking, what we do is we assign a unique ID to each of the detected object. So when a new object enters the scene, that object is being assigned a unique ID, and until the object remains in the scene, that object is being assigned with that ID. We will go into more details as we start coding. So let's get started. So here you can see that I have created an empty folder by the name YOLO-NAS DeepSORT video for this project. So now I will just go to a PyCharm and create a new project over there. So let me just open the PyCharm. So now here you can see that I have just opened the PyCharm Community Edition. I will just click on File and click on New Project from here and just select the new project directory from here. And it will be the directory in which I have just created this folder, and it is inside this, and the name of the folder is YOLO-NAS DeepSORT video. So just select this folder and just check this if this path match. Okay, so the location of the new virtual environment also matches, and we are using base interpreter as Python 3.10. So now just click on create a new project, and in this window, so now you can see that it's now creating a virtual environment. So this might take few seconds before it's ready. So this might take few more seconds. Okay. So now you can see that we have created a new project into our directory, which I just shown you. And first of all, we will just install all the required libraries. So I will just create a new file by the name requirements.txt. And in this file, I will list all the required libraries over here. And we just need two libraries, super gradients, and the other is opencv Python. So to implement YOLO-NAS object detection algorithm, we require the super gradients package. So to implement YOLO-NAS object detection algorithm, we require the super gradients package. Plus to do processing on the video, to display the input or output video, and to use different functions of opencv in our code, we require the opencv Python package as well. So I'm just using super gradients package to run object detection using YOLO-NAS, and plus to do video processing and to use different functions of opencv Python in the code, we require the opencv Python package as well. So just write opencv Python. So we just need these two libraries, super gradients and opencv Python. So I will just go to the terminal and just write pip install -r requirements.txt. As we will be integrating object tracking using DeepSORT, so we just don't require any package for this currently. So we just require these two packages which I have listed over here. One is super gradients and other is opencv Python package. So just write pip install -r requirements.txt and then click on enter from here. So if these packages are not already installed, they will get installed, and it will take some time, around 5 to 10 minutes. But here you can see that it's appearing requirements already satisfied because I've already installed these packages. But if you haven't installed those packages, this will take some time. Next, what you will do is you will just click over here and just create a new .py file over here and just write object tracking.py. Okay. So now here in the first step, I will just write the code to do object detection on a video. And in the next step, we will integrate object tracking using DeepSORT, and then we will test it on videos as well. And in the next, the last step, we will be training our YOLO-NAS model on a custom dataset. and then we will see how we can integrate YOLO-NAS with DeepSORT object tracking on a custom dataset as well. So let's first do object detection on a video. The first step, I will just import all the required libraries. So first of all, I will import the opencv Python library by writing import cv2. In the next step, I will just import the torch library, import torch. Then from super gradients. So to implement object detection using YOLO-NAS, we require the super gradients package, as I've already told you. From super gradient.training, import models. We also require the NumPy package. We will require it when we will integrate object tracking using DeepSORT. And we will also require the import math package. We will also require the math package because we will use this package when calculating the confidence score. So next, what we will do is we just need to read a video. So to capture the video or read the video, we will using cv2.video capture function. So first of all, I will just create a directory over here by the name video. And in this directory, I will add some videos over here. So let me just go to my required folder. Just give me a minute. I'm just navigating towards it. So now, as I told you, I've created a directory by the name video into my YOLO-NAS DeepSORT video folder. And inside this video directory, I have added multiple videos. So these are around 10 different videos, which I have added in the video directory, which I have created in the PyCharm. So let's go towards the PyCharm. So if I just now see over here in this video directory, you can see we have tens of videos. So let's read a video and let's see how we can do object detection on a video using YOLO-NAS. So I will write cap is equal to cv2.video capture, and I will just go to the video folder and I will just read bikes.mp4. Okay. Then let me just calculate the frame width and frame height. We need the frame width and frame height because we will be saving the output video. Exactly. So we are just calculating the frame width and frame height now. And now I will write over here device is equal to torch.device So if you have GPU, you can use the GPU, but in my local system, I don't have my GPU, so I will be using CPU. If torch.CUDA is available, else torch.device. So if we have GPU available, I will be using GPU, but in any case, if I don't have the GPU available, I will be using the CPU. So in the last step, we will see how we can integrate object tracking or how we can integrate YOLO-NAS with DeepSORT object tracking on custom dataset. But this we will see in the last step. But currently, we will be using the pre-trained YOLO-NAS weights. All right, model is equal to models.get. So in this project, I will be using YOLO-NAS small model. YOLO-NAS comes with 3 different models: YOLO-NAS small, YOLO-NAS medium, YOLO-NAS large. YOLO-NAS small is the fastest, and YOLO-NAS is the fastest, but it is less accurate as compared to other YOLO-NAS models. But YOLO-NAS large is the most accurate, but it is less fast as compared to other YOLO-NAS models. So YOLO-NAS small is the fastest, but it is less accurate, while YOLO-NAS large is the most accurate, but it is less fast. So we will be using the pre-trained weights as Coco and to device. So here I will be initializing the count as 0. We will just doing the frame count. So I've just initialized the count here as 0. And as I just want to save my output video, so I will be using cv2.video writer function to save the output video. My output video will be saved by the name output.avi. And I will write cv2.video writer dash 4cc mjp G, and here I will be just passing the frame rate, and here I will be just defining the frame width and the frame height as well. Okay. So here I will just write while true and here I will write red comma frame is equal to cap dot read, and if red results is equal to list model dot predict frame, and here I will be just setting the confidence score as 0.35 and then click on enter. And here I will be just calculating the bounding box coordinates over here. So here in the first step, we will are calculating the bounding box coordinates. Yeah. And just converting them into the list format over here. And in the next step, now I will be just calculating the confidence score over here by just writing confidence is equal to result dot prediction dot confidence. And then I will just click enter. And now I will be just finding the class and number. Label is equal to result. Labels is equal to result dot prediction dot label dot tool list. So we have the bounding box coordinates value, we have the confidence score, we have the labels here as well. So now we'll loop through each of the bounding box, confidence score and labels, and we just create the bounding boxes around the detected object, assign it the confidence score as well as the label. All right, for label shape confidences labels. So that's fantastic. And here I will just write this. So now we will be just calculating the coordinates. So for each of the bounding box, we have 4 coordinates, x1, y1, x2 and y2. So for each of the bounding box, we have the 4 values or 4 coordinates values, x1, y1, x2, y2. So x1, y1 represent the top left corner of the bounding box, and x2, y2 represent the bottom right corner of the bounding box. So I will write x1, y1, x2, y2. bbox 0, bbox 1, bbox 2, bbox 3. So here we are just putting the coordinates of the bounding box over here and just copy this from here. So currently this output is in the form of tensors. We are just converting it the output from tensors into you can say that into integers. Okay, so we have converted the output from tensors into integers. Just change it to CLS for to make things easy further, and just write over here class name is equal to int CLS. So basically, we are using the pre-trained weights of Coco dataset over here. So Coco dataset consists of 80 different classes. So I will just add the class names over here. So let me just copy the class names. Okay, so these are the 80 different classes which we have in the Coco dataset. So I've just added those class names all over here. And next thing which we can do over here is name is equal to okay, so now we will have the class name, and now we just need to calculate the confidence. Confidence equal to mat.seal. So here we have calculated the confidence score over here as well. So here I will just write label is equal to class name confidence. So we have the label as the class name and the confidence score. So now we will just calculate the text size over here. So I will use cv2.getTextSize function for this to calculate the text size. So here we have calculated a text size over here, which you can see as well. So now we will make some adjustments into the rectangle, the rectangle which will create above the bounding box. So now I will be just creating a rectangle around each of the detected objects. So now we will be creating a rectangle around each of the detected object, or you can say that we will be creating a bounding box around each of the detected object. So for this, I will be using cv2.rectangle function. So here I have just passed the coordinates of the bounding box. For each of the bounding box, we have four coordinates. X1, Y1 represent the top left corner, and X2, Y2 represent the bottom right corner, and the color of the bounding box will be, which I will define over here. The color of the bounding box will be sky blue. So now we have created a bounding box around each of the detected object using cv2.rectangle function. So after creating a bounding box around each of the detected object, now I will just create a rectangle above the bounding box in which I will just put a label and the confidence score, or I will just add the class name and the confidence score. So just add the same color over here as well. Okay, so just copy this from here and just add this over here and just change it to, because we don't want our bounding box rectangle to be filled, so just change it to thickness of the bounding box rectangle will be 3. And using cv2.putText function, I will be adding the text inside the bounding box. So that looks quite good. So using cv2.resize function, I will just resize the frame so that it fits on my screen. Now I will just show the output here as well. So here we have our output, and just write few lines to be written over here. Output out dot release cap dot release cv2 dot destroy on Windows. Okay, so let's run this script now and let's see what we get over. So let's see whether we are able to do object detection using YOLO-NAS on the video. If we are able to do object detection using YOLO-NAS on video, then in the next step, we will integrate a DeepSORT object tracking with YOLO-NAS. So if there is any error, we will try to fix it up. But if it, okay, new module name. Okay. Okay, so the spellings were not correct. It is super bits. So let's see how does it goes. If there is any error, we will try to fix it up. So this might take few more seconds before. Okay. There was spelling mistake. Now let's see how does it goes now. Okay. So here we have also have a mistake. It should be B boxes. Okay, so now let's see if there is any error or if it works fine. So here we have the error. So it's labels over here. Okay, okay, it started, but it just end quickly. So let's see what's the error. Okay, so here is the error. It should be 0. Okay, so I hope it will work fine and we will have the output in front of us. So this might take few more seconds to execute. So let me just navigate my screen towards the output video. So here you can see that we are able to do the detections. So we have done object detection using YOLO-NAS. You can see over here, we have detected the traffic lights, we have detected a person, we have detected a bicycle, we have detected the handbag, we have detected a person. So the detection results look good. Like you can see over here, we are able to do object detections using YOLO-NAS. So here you can see that we have detected bicycle, we have detected person, we have detected a handbag, we have the label like bicycle over here, we have the confidence score like 0.96, which means the model is 96% confident that this is the bicycle. Here, the confidence score of the person is 0.41. This means the model is 41% confidence that 41% confident that this is the person. So now you can see over here, we have done object detection using YOLO-NAS. Here you can see we have detected a traffic light and the confidence score is 0.76, which means the model is 76% confident that there is a traffic light. So the detection results look impressive. Let's go back towards the code. So you can see that we are able to do the object detection using YOLO-NAS, and we are able to do the object detection very successfully. We have created bounding box around the detected object. We have assigned that each of the detected object a label and the confidence score, as well as we are also able to do small object detection very perfectly using YOLO-NAS as well. Okay, so now let's integrate DeepSORT object tracking algorithm into this object detection using YOLO-NAS algorithm. So now we will just integrate DeepSORT object tracking algorithm into it. For the object tracking, I will be using DeepSORT algorithm. So you can just write over here DeepSORT GitHub and just go to this GitHub repo over here and you can just download this DeepSORT file from here. So I have already downloaded this file. So what we basically do in object tracking, we assign a unique ID to each of the detected object. And for here object tracking, I am using DeepSORT algorithm. So you can just download this file from here, deep-sort. You can just download this complete folder from here, or you can just by just cloning this repository, you can just download the zip complete repo from here, and you can just take up this folder DeepSORT over here. Okay, so let me just go back towards the code. So now here you can see I have just downloaded this complete folder DeepSORT.pytorch over here, and here I have all the required files. I will just add this folder I have just into the GitHub, and I will just share the link with you as well. I will just add this folder into the GitHub repo, in my GitHub repo, and just share with the link with you as well. So you can just download this folder from here. Before we go ahead, let me show you, we have launched 3 courses on Udemy: YOLO-NAS, the ultimate course for object detection and tracking. So this is the pro course, which cover various topics, and we have done object detection, object tracking using YOLO-NAS. We have done around 10 different projects or 12 plus projects, which you can see over here. And we will go step by step how you can train YOLO-NAS on custom dataset. Plus, we have implemented some real world projects which include license plate detection, plastic bottles counting, privacy blurring, vehicles counting, fire detection, face mask detection, real-time sign language alphabets detection, and many other projects. You can just check it out over here. Plus, we have two other courses available as well, which you can see over here. We have the YOLO V7, YOLO V8, YOLO-NAS Object Detection Tracking course. You can see that 190 students have already enrolled, and that it is the one of the bestseller course on the Udemy platform, and the rating of the course is 4.6. So the numbers speak itself. This course contains 19 hours on demand video, and you can see over here there are huge number of projects which we will cover. There are around 22 plus real world projects, 22 plus real world projects, which we will cover. So in this course, we have just discussed YOLO V7, YOLO V8, YOLO-NAS over in this course, and it is the best seller course on Udemy platform. Captions are also available, and it contains 91 downloadable resources, 19 hours on demand video. You can see over here, and here you can see we have all the content. So we have around 20 plus sections in this course. And in this course, we cover the YOLO V7 web development, YOLO-NAS app, YOLO V8 apps as well. Plus, we have other course available on Udemy platform as well, which is YOLO V8 object detection. So the rating of this course is 4.4, and this is also the bestseller course on the Udemy platform, and 301 students have already enrolled. And this course contains 12 hours on demand video, and here you can see this is the content of the course, a huge content this course covers. We will see how we can do web app development, and how we can integrate YOLO V8 with Flask, and how we can create a complete web app as well. So you can just go to these courses, and you can just try out any of this course. So for all of my YouTube fellows, I am just offering 50% off in all my courses. So currently the course price is $19.99. But if you just click on the link in the description provided in this YouTube video, you will get straight 50% off. So if you just click on the link in the description provided, you will get 50% off. So what are you waiting for to check out these courses? So now here you can see that as we are implementing object tracking using DeepSORT. So here we have the DeepSORT pytorch folder, and here we have all the required files over here. I will just add will just add the link of this folder in the description. You can just using that link, you can just download this folder. So I will just add the link of this folder in the description. So you can just download this folder by clicking on the link. So we will be doing object tracking using DeepSORT algorithm. What we do in object tracking, we assign a unique ID to each of the detected object. So first of all, we will just import the required libraries so that we can implement object tracking using DeepSORT and integrate it with YOLO-NAS algorithm. So right from DeepSORT pytorch, we are utils dot parser get configuration, and then I will just click enter. So here I will just initialize few functions of the DeepSORT over here. And just add this file path over here. So just copy this path from here and just add this path over here. Okay. So that's look pretty good till now. So now here I will just initialize the DeepSORT. So it is a long line of code. So I will just take it from my previous written script. Mhm. So now here you can see that I'm just initializing the DeepSORT over here. Okay. So here we have initialized the DeepSORT. So that's look pretty good. Okay, so just copy this from here and just add this over here. That's look good over here. So now we will just comment out some previous code. So just comment out all this from here. So let me just I've just commented out all this from here, and here I will just write the updated code. First of all, we will just calculate the center coordinate. So basically, DeepSORT requires the output or the input in the form of basically what we output we get from YOLO-NAS object detection algorithm. We just pass that output into our DeepSORT object tracking algorithm. So DeepSORT algorithm required the output in the form of center coordinates and width and height of the bounding box. Here we are just calculating the center coordinates of the bounding box. So now we will be calculating the bounding box width and height as well. So now we will just converting into the format so that we can just pass this output received from the YOLO-NAS object detection algorithm into our DeepSORT algorithm. So in this output from the YOLO-NAS object detection algorithm will be passed as input to the DeepSORT object tracking algorithm. I will be now creating 4 empty lists over here. Okay. and I will be just appending these values into this list. So I will just append these values into this list over here. So just copy this from here and just add this over here. So that's look fine till now. Just make this change over here. So that's look fine as well. And just copy this from here and just add this over here. Oh, this is my mistake. And here I will write outputs is equal to, and here I will write if length outputs is greater than 0, and now I will be using the draw dash boxes function. I have not created that function, so I will just create a function by the name draw dash boxes. So I will just creating the function above over here. So let me just create a function by the name draw dash boxes over here. So I will write define draw dash boxes. I have already written this code for this function, so I will just add this code because this video is getting very long. So I will just add the code for this function, which I have already written. So I will just explain you the code. Oh, okay, let's write that function because let's do it in front of you. So just calculating the bounding box coordinates over here again. I'm just writing over here x1, x2, y1, y2. So now I will be using cv2.getTextSize function over here as well to calculate the text size. So I will just go over here and just copy this code. So I will just go down below again and just copy this from here and just copy all this from here and just add up this code over here again. And let me just update this all from here as well. So this is the text color which I have defined over here. So let me must make the color of the bounding box as sky blue and the color of the label and confidence score as yellow. So that's look quite good already. Let's see if there is any error. Okay, so this will be return image. Okay, things look good. Let's see whether we are able to implement object tracking using DeepSORT over here as well. So let's run this script and let's see what results do we get. So this might take a few seconds before it is ready. Let's see if it works fine or there is an error. Let's see what is this error. Wait, it. Okay, so here is the error starting. Let me look into this error. One thing I see is I'm not calling this draw dash boxes function. So just copy this from here and just write draw dash boxes and write here frame vbox dash xy identities object ID. Okay, so let's run it again. And let's see what is this error if it appears again. Let's see how does it goes. Okay, so we have the same error again. Okay, let me just check it. So I've just found out the error. So this is not correct. Just copy this and just add this in the torch.tensors and just make it frame. And let's run it again and let's see how does it goes. So if there is any error, we will try to fix it up. So now here you can see that we have integrated object tracking with YOLO-NAS object detection algorithm. But you can see here the rectangle is not filled like we just want this rectangle to be filled. So I will just go back to the code and make some changes into my code. So I will just go above this function. Okay, and here I will just update this. I will just add -1 over here, and this will make it work. So let me just pause this and let's run it again and let's see what results do we get. After do this, we will just see how we can do object tracking using YOLO-NAS on any custom data set. So let's run it and see what results do we get. So let me just show you the output. So here is the output. You can see that we have assigned a unique ID to each of the detected object, like 1 for this person, 6 for this bicycle, 58 for this bicycle, 26 for this bicycle, 66 for this person, 21 for this person. Although you can see this person standing far away, but using YOLO-NAS object detection algorithm, we are able to detect the person. So now here you can see that using DeepSORT object tracking algorithm, we are able to detect the object, and using a YOLO-NAS object detection algorithm, we are able to detect the object, and using DeepSORT object tracking algorithm, we have assigned a unique ID to each of the detected object. Like you can see here, 1670 with tourist handbag. So these IDs are not assigned like in the numeric order, but these IDs are being assigned randomly, like 66, 81, 58, 26. So these IDs are being assigned in randomly. They are not assigned in the sequence order. So now you can see over here, using object detection algorithm, using object YOLO-NAS object detection algorithm, we detect the object, we create bounding boxes around each of the object. Plus, using DeepSORT object tracking algorithm, we assign a unique ID to each of the detected object. Using DeepSORT object tracking algorithm, we track the detected object throughout all the frames until the object is in the scene, and when the object leaves the scene, that ID is removed. So a unique ID is being assigned to each of the detected object, and we track that object using that ID throughout the frames. So in using object detection using YOLO-NAS, we detect the object, create bounding boxes around them, and using DeepSORT object tracking algorithm, we assign a unique ID to each of the detected object, and that ID remains with that object until that object is in the scenes, so that we can track that object. You can see our 16, 14, 10, 1, 106, and these IDs are not assigned randomly, are not assigned in the sequence order. These IDs are assigned randomly. So now I will just show you the Colab code. Using that Colab code, we will be training the YOLO-NAS model on a custom data set. And then we will just add this custom model weights over here, and we will be doing object tracking using YOLO-NAS on a custom data set. So here you can see the data set. I will be training the YOLO-NAS model on this data set. The data set consists of 4,680 images, and we have 10 different classes in our data set. So these are the drone images of boat, camping car, motorcycle, pickup, plane, tractor, truck, van. So these are the drone images of different vehicles. And you can see over here, let me just go to the health check. So the dataset consists of 4,681 images with 20,554 annotations. Out of 20,554 annotations, 18,389 annotation belongs to the car class. So the car class is overrepresented, while 682 annotations belong to the pickup and 421 annotations belong to the motorcycle class. So the car class is overrepresented, like it contains majority or 90% of the annotations, while 10% of the annotations belong to the remaining 9 classes. Okay, so I will be just training the YOLO-NAS model on this data set. So here is our Google Colab notebook. So I will be training the YOLO-NAS model on this data set. I have already trained the YOLO-NAS model on this data set. As I told you, I've explained you already how you can train the YOLO-NAS model on any data set. So I've already trained the YOLO-NAS model on this custom data set, and I have saved my model weights, the best model weights already. Okay, so using those best model weights, I will be doing the car vehicles detection. Like you can see over here, you can see we have detected the cars. So I've just saved those model weights. So let us just go back to the Google Colab, our PyCharm script, and just add these model weights. And let's test this, or let's integrate object tracking with YOLO-NAS on custom data set. Okay, so I've already explained you how you can train or fine tune YOLO-NAS model on, like you can say, on any custom data set. So here is the output video of this. Like you can see, currently we are only doing object detection using YOLO-NAS on a custom data set. So if you just want me to, I will just share this Colab script file with you as well. So I've already saved the best model weights, so let me show you the best model weights and then we will go ahead. So here you can see that this is my project folder, and here I've created a directory by the name weights, and inside this weights directory I've just put my best model weights, which you can see over here. So let's go back to the PyCharm and let's do object tracking using DeepSORT on custom data set. So let me first just comment this out from here and just write. So we have fine-tuned or trained the YOLO-NAS small model on this drone images of data set or drone images of vehicles, as we have 10 different classes in our data set. So now I will just add the class names. I will just go back to the Colab notebook file. So you can see that here we have the 10 classes name in our data set. So just add these class names over here. And let's run it and let's see whether we are able to do object tracking using YOLO-NAS and object tracking using DeepSORT algorithm and object detection using YOLO-NAS on custom dataset as well. So now here we are integrating YOLO-NAS object detection and object tracking using DeepSORT algorithm to do object detection and tracking on a custom dataset. So let's run this script now. Here you can see that we have a weights folder and here I have my best model weights over here. So this might take few minutes. Okay. Checkpoints. Now I think there is an issue in the name. So let's run it again. One thing I have not corrected is basically I have not added the correct video path. So just add me test 2. Okay. Let me just run it again. So now we will be doing object detection and tracking you on a custom data set, which is drone data set images of vehicles. So here we are doing object detection using YOLO-NAS and object tracking using DeepSORT algorithm on a custom data set. So let's see, this might take few seconds to execute. So here is the output video. You can see over here, we have detected the car. You can see that we have assigned a unique ID to the car. Like you can see 5 here, 3 here, 20 here, 18 here. So now you can see that we are able to do object detection using YOLO-NAS, and we are doing object tracking using DeepSORT algorithm on a custom data set. So we are using object detection using YOLO-NAS and object tracking using DeepSORT algorithm on a custom data set. Using object detection, we detect the car or it is a pickup, and using object tracking, we assign a unique ID to each of the detected object. Like you can see 44, 12, 3, 20, 40, 18. So each of the detected object is being assigned a unique ID using deep sort algorithm, and for object detection, we use YOLO-NAS. So the results look cool. The results look impressive. Like you can see over here, 54, 55, 40. So each of the detected object is being assigned a unique ID using deep sort object tracking algorithm. So the results look super cool. It's amazing. And let me just go back towards the code and let's test out on some other video and let's see what results do we get. So just write test4.mp4 and let's run on this video and see what results do we get. So here is the output video. You can see that we are able to detect the car, and when you can see over here, we have assigned a unique ID 9, 4, 2, 15. So these IDs are not assigned in a sequence. These IDs are being assigned randomly. So you can see that we have detected the object. We have assigned a unique ID to each of the detected object like 1, 20, 15, 5, 7, 13 to this van, 10 to this car, and so this is what we do in object tracking. We assign a unique ID to each of the detected object. And for object detection, I'm using YOLO-NAS. So here you can see that we have tested on 2 different videos and the results look impressive. So here we have seen that how we can do object detection and object tracking on a custom dataset. For object detection, I'm using YOLO-NAS, and for object tracking, I'm using DeepSORT algorithm. So that's all from this video tutorial. I hope you have learned something from this video tutorial. See you all in the next video. Till then, bye bye.